Hi everyone, and welcome to my second tutorial about the isomers. So we shall continue with the E and Z, isomerism. So these are today's objective. We look at the priorities found when naming E and Z isomers. So the first priority, we shall look at the atomic number, and the second one, if we have a tie, what do we do? Then on the third, we shall look at the presence of a double and a triple bond, and then lastly, presence of any isotopes. So now, to begin with the atomic number, so if I have a structure like this, so now if I have a molecule like this and I would like to name it under E and Z. So remember I said that if we have molecules, if you have both priorities on the same side, high priority, and low priority on the same side, this qualifies to be Z, like same, them. Whereas if you have a mixture of high and low on the same side, then it qualifies to be an E. So now on this molecule, if we use what we call the atomic numbers, so we shall determine which of these is having a higher or a low priority. So on this carbon, we always look at this carbon and see what other atoms are bonded to it. So now on this side, we see that this carbon is bonded to a carbon on this other side. If I write it here, a carbon on this other side and a bromine atom on the other side. So when we look at the atomic number, so the atomic weight, bromine is more heavier than carbon. So therefore, bromine will take a higher priority. So now this takes our first higher priority. Then we go to this other second carbon. So on this other carbon, we have this carbon is bonded to another carbon and also to a chlorine atom. We know that chlorine weighs heavier than carbon. This is atomic number 6. This is atomic number 17. So therefore, chlorine is more heavier than carbon. So this will take the higher priority. So now, since we have two higher priorities on the same side, this qualifies to be a Z isomer. So this is how we name, we identify elements as Z, either Z or E isomer. So in another example, what if I had, instead of Br here, if I had a bigger molecule like iodine. So remember, iodine is heavier than bromine, so therefore this will take a higher priority. So if this takes my higher priority, and on this side chlorine takes the higher priority, then we shall have what we call a E isomer, because we have a high and high in the opposite side, like in the trans side, so it qualifies to be an E isomer. So now, if we step down to the second priority that we follow, what if the compounds, what if we get a tie? How do we solve it? So, for example, if I may change this to a carbon CH2 and CH3 here, and CH2 to CH3. Now, what if we have a tie? So when you look at this carbon, is bonded to another carbon and another carbon. So now that's a tie because these two carbons are both bonded to two hydrogens. So now this and this is the same. So now from that we jump to the next available atoms. So now this other carbon was bonded to a carbon, this carbon here. Now we are done looking at this carbon. Now we are looking at this other carbon. So this carbon is bonded to another carbon and bonded to two hydrogens. So this carbon is bonded to two hydrogens and this other carbon. So if I may elaborate more to show you how the bond exists. So if this is my CH2, then this next carbon is bonded to 2 hydrogens and this other carbon, right? So this carbon and 2 hydrogens, whereas this carbon here is bonded to 1, 2, 3 hydrogens. So this has 3 hydrogens, but this has a carbon, a hydrogen, and a hydrogen. And we know that carbon has a higher atomic number than hydrogen. So therefore, this molecule will be our priority. So then we go to this side, chlorine will take our higher priority. So now this molecule, since it is on opposite sides, then it is an isomer. So let us do another one. Let us use another compound. So to elaborate, now we've seen how we can solve for a tie. When you have a tie, you always go to the next other carbon. So if there is no next other carbon, then the carbon that has a longer chain then wins the priority. So to go to the third objective, the presence of a double or a single bond. So if we have a compound like this, and so if we have something like this, so we see that this carbon is bonded to 2 carbons and a hydrogen, and this carbon is bonded to 1 carbon and 2 hydrogens. And on this other side, we have this carbon with a double bond and then another carbon. Then this has 2 carbon atoms. So now on this side, let us decide which side takes our priority. So we drop down to this other carbon, this carbon and this carbon. So this carbon is bonded to this other carbon and this other carbon and this hydrogen. So it is bonded to CCH. Whereas this carbon is bonded to this carbon and 2 hydrogens. So this has carbon, hydrogen, hydrogen. This has carbon, carbon, hydrogen. So this takes a higher priority. So this takes our priority. Then we go to this other side. So this carbon is bonded to a carbon and a carbon. So this other carbon again is bonded to a carbon and 2 hydrogens. Whereas this carbon is bonded to a hydrogen. So now if we have a double bond, we take those to be 2 carbon atoms. So we shall say this carbon is bonded to hydrogen and 2 carbon atoms. So we shall have hydrogen, carbon, carbon. Here we have carbon, hydrogen, hydrogen. So this takes a higher priority because we have 2 carbons this side and we have only 1 carbon this side. So this takes a priority. So if the 2 priorities are on the same side, then that qualifies to be a Z isomer. So the same applies to the triple carbon. To the triple bond. If you have a triple bond, then we consider this to be 3 carbons. Then lastly, if we have any isomer. So for the isomer, I'm going to use a simple, let me use ethane. So remember, ethane has hydrogen, 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 and hydrogen. So now, if I use an isomer of hydrogen, deuteronium, D, represented by D. So remember that an isotope has a higher mass number. So therefore, D will take priority because it has a higher mass number. So therefore, this will be my priority. So if I could change this to maybe a chlorine atom. So this will take my priority, and on this side, the chlorine will take my priority. So I'll have an E isomer. So basically, the presence of an isotope. So the isotope with the highest mass number always takes priority. So thank you very much for watching. Catch you next time as we discuss conformers. Bye for now.